Hello and welcome back to the CCNA journey with me, Ryan, and in this video we're going to focus on the network access still. So that's the second part of the second section of the CCNA, and within that we're going to look at the spanning tree protocol. Now Cisco has outlined in the blueprint that they want us to focus on the Rapid per VLAN spanning tree, and that's what this video is going to focus on. There may be references to other types of spanning tree, and I'll explain if so and why, but for now all we need to be aware of for the CCNA is the Rapid per VLAN spanning tree. For those who don't know, you can contact me here on YouTube, you can connect on LinkedIn, follow on Twitter, or speak to me on Facebook. Okay, let's get started. So let's go over and talk about spanning tree protocol. Now the spanning tree protocol itself is a bit of a beast, especially as you get more complex into how it actually is created and the additional options that have been implemented through multiple RFCs as the protocol has actually evolved. But the thing with spanning tree is if you keep it at its heart and keep it simple, it really is a simple protocol. There is such a thing as common spanning tree protocol, there's multiple spanning tree protocol, there's rapid spanning tree protocol, all of which are kind of valid protocols in the sense of how we do spanning tree. However, they all follow the same simple rules, which of course is to prevent loops at layer 2, and they all do it using the same methods. They find root bridges and they find the best path to the root bridges. So what you're going to learn at your CCNA is fundamental in understanding spanning tree, and as long as you keep that fundamental in place as you progress through your career as a network engineer, spanning tree won't be so scary to you because that principle is always there. A lot of people forget that principle and get overwhelmed by the complexity that comes with spanning tree. And the other thing with spanning tree is it's not so much the complexity, but it's also the undesirable state. However, most scenarios with the undesirable state is driven by poor design or spanning tree not being used the way it's supposed to be used. So there are ways to prevent that. You learn about this in the CCNP design through building up domain blocks or basically limiting the layer 2 failure domain, but that's beyond the scope of the CCNA. For now, at the CCNA, all we have to know is why spanning tree is required, how to set it up very basic, and some of the additional options that come along with spanning tree. So let's get started. First things first, it prevents loops at layer 2. So let's have a discussion around what I mean by that. Now this triangle that I'm sort of drawing out now is a typical spanning tree sort of topology you'll see everywhere. Everyone tends to use this to explain spanning tree, and effectively it's just 3 switches in a triangle, and there's 2 PCs trying to communicate with each other. Now I'm not going to go over the switching process because you should know that based on my previous videos, but I will go over what happens at a high level. So let's say, for example, we have the PC up here with an IP address of 1.1.1.1, and we have the PC down here with 1.1.1.2, and they're part of a /24, so they're in the same subnet. I've asked this PC at the top to ping the bottom PC. This PC looks in its ARP cache, the address resolution protocol cache, and it's looking to find out what is the MAC address of that remote PC, so I can build the layer 2 frame, the layer 2 Ethernet frame to send out my actual segment. However, when it looks inside its cache, it doesn't see any data there because it's yet to learn about this end host, and because of that it sends out an ARP resolution protocol, an ARP, and when it sends out that ARP request, it will send it out as a broadcast frame. So when the traffic leaves this router, it leaves with the all Fs, and when the switch receives this broadcast frame, it knows to flood the data because the switch needs to flood the data. Because let's also assume that this is a brand new network and the switches do not know about the host. So this switch receives the data in on this port and it floods it to both switches. The only place this switch does not flood it is back the way it came, because the rules of switching state, when you flood traffic, you flood it everywhere apart from the port you received the request on. Now what happens down here? This switch receives it, floods it down to the PC, and also floods it across to this switch. This switch receives the flood from the top and forwards it to this switch. Then what happens is this switch here received the flood from this switch and floods it back to the original switch, and then when the flood came down here and went across, this switch floods it to this. This switch now receives both floods, sends it back down either way and back to the PC, and effectively what we have here is a continuous loop. This will continuously to loop throughout the entire network, throughout the 3 switches, until all of the switches hit a CPU of 100% and unable to pass any legitimate traffic, because this single one flooded packet from one PC destroyed the entire layer 2 domain. That is what happens if spanning tree does not exist. Now, why does that happen? Well, if we look at the layer 2 header, the layer 2 header is an Ethernet header. And inside Ethernet, there is no what we call TTL, time to live. TTL is at layer 3. Just so we're on the understanding here of TTL at layer 3, let's say, for example, we have a series of routers that are connected like so. And let's say that this is network A, network B, C, and D. And network A believes that the final destination for its traffic is through B, B through C, C through D, and D through A. So you end up in a loop scenario. So what I mean by that is A says, I need to get to destination X is to B, B thinks destination X is C, C thinks destination X is D, D looks at his routing table and thinks he has to go to A, and A passes it back to B. So this could happen quite easily in a layer 3 network. However, what happens is in a layer 3 packet, there's actually a TTL field. Now that TTL starts at different values depending on the protocol and so forth, but let's just say it started at the value of 10. Well, as A passes it to B, and B decaps, as in decapsulates that packet, and encapsulates it to send it towards C, it will actually decrement that 10 to a 9, and the same when C decaps it and encaps it, it will change it to an 8, D will change it to 7, A will change it to 6, B will change it to a 5, C 4, 3, 2, 1, and then effectively when it's received again, it will then be discarded. So what happens is that this loop that we've created here at layer 3 will effectively, after a period of time, depending on the value of the TTL, but nonetheless it will happen, the value will be discarded. It will be dropped by a router. Now the TTL value can be something like 256, I think it is, or 254, I think it's 256. But nonetheless, it can be high, and then obviously it will take a lot of hops for it to be discarded, but it can be and will be discarded at some point if it does not reach its destination. And that is what is not happening at layer 2. There is no TTL, and because of that, we have to come up with a layer 2 loop prevention mechanism, and in this case, we're using the spanning tree protocol. So there are a few options. Prior to spanning tree, your only option was to create networks that didn't have loops. So for example, in this scenario, what we would do is we could delete this link here, and then traffic would flow perfect to our PC, because there is no way the traffic will loop back on itself. Because remember that rule that we mentioned at the beginning, when traffic is flooded out of a switch, it will never flood it of the way it came in. So because of that, you end up in a very nice scenario where there's no loops. But the downside is if there's a break in the cable, then we have to bring up a second cable by either no shutting the port because it was plugged in but disabled, or sending an engineer to plug a new cable in. But that's not ideal because we don't know when failures are going to occur, and we might not be available to do that. And of course, until that second port comes up, we've effectively taken down the network, and that's not acceptable in this day and age. So spanning tree came about in a way to kind of solve these issues by creating a loop-free topology between or within the layer 2 domain. So that's something to keep in mind. We know now why spanning tree is needed. It's needed to prevent those layer 2 loops. We don't need it at any other layer because they have the TTL value, the time to live value. Layer 2, we don't have a TTL value, so you have to have some clever mechanism or some deterministic way to determine where the traffic will go and how loops are prevented. And this is the need for spanning tree. So hopefully that was straightforward. I know again spanning tree can be very, very confusing, and it might take multiple times from watching the video or going across multiple resources to understand it. But effectively, that's what spanning tree does. Now, I've put here an interesting comment. I said it allows us to create redundant or multiple links between switches. Now, if you're watching my video series in order, you've just come from Ether channel, and you're probably thinking to yourself, hang on a minute, I can create multiple links between switches using Ether channel. Now, Ether channel is actually the fix for this, but let me explain the problem that spanning tree actually has without the use of Ether channels. So, we know from the previous video that an Ether channel is where you bundle multiple physical ports to create a logical port. We know that. We've looked at it in the lab, we got it set up, we saw the behavior. Well, let's say, for example, we have 3 cables between these 2 switches and there was no Ether channel. Okay, and it's important to know that because with Ether channel, this behavior will completely change. And you might remember that I mentioned in the previous video, Ether channel helps the spanning tree protocol. Well, this is what I meant by that. Now, we've got our 2 switches, we've got 3 cables between them. Now, the spanning tree protocol will look at this and go, it's actually a problem here, isn't there? Because remember the flooding rule? The flooding rule is I won't send it back out the port it came in on. But if this switch sent a flood down here, sending it out of this port isn't the port it came in on. So what you actually end up with is, even though there's 2 switches and there's multiple cables between them, you still end up in a full loop situation, which means that if you plugged these 3 cables like this back to back and you turned off spanning tree, you will bring your network down. Now, what spanning tree will do when it looks at this is it will actually end up disabling 2 of these ports, and you can effectively only ever use 1 of these ports. Okay, now before you say anything, there are multiple ways to use the other ports in spanning tree when you can actually load balance VLANs over them, but that is outside the scope of the video. For now, we're just talking about normal rapid spanning tree, not per VLAN rapid spanning tree. So that's just for those who are out there watching this video going, oh, I got a way to do that. So there is ways, there's always a way in networking, but let's just go with this for now. We're doing a single VLAN across this. And for those who don't know what the hell I'm talking about, don't worry, it will come clear. So we have 3 cables connected between 2 switches, and spanning tree has disabled 2 of those cables because the only way it can guarantee loop-free information between these 2 switches is to only have 1 cable active. The other cables must be disabled. Well, if we then created it as an Ether channel, what are we left with? Well, we're left with 1 port, aren't we? Sure, there's 3 physical cables, but there's 1 port. There's 1 Ether channel. There's 1 port channel. Because of that, spanning tree allows us to actually have all 3 ports enabled. But from a spanning tree calculation perspective, it calculates it as 1 port, and it's 1 lag, 1 Ether channel. And this is what it allows us to do effectively. And when I said in the previous video, Ether channels help us with spanning tree, this is what I mean. A good way to create multiple redundant links between switches that doesn't necessarily break spanning tree, or spanning tree doesn't end up disabling your ports, is through the use of an Ether channel. So that's it. That's important to know. However, that's a little bit off topic to what my actual comment's actually supposed to be telling you about, because the comment says allows us to create multiple links between switches. Well, without spanning tree, we could never have 3 cables like this, because again, they would loop. But with spanning tree allows us to have these cables in place and ready but it will automatically disable 2 of them. And when the primary link were to fail, it will automatically bring up the second link ready to pass traffic on that circuit without having to get an engineer out of bed to do something. So that's what I mean by it allows us to create redundant and multiple links between switches, which it does, but depending on how you set up spanning tree, it might mean that only one of those links are active at one given time, unless you use something like an ether channel, or unless you start load balancing VLANs over the different links, which I'll come on to in a different video. Okay, hopefully, I know this is a lot of information, hopefully it's good so far. Now, I mentioned already there are plenty of different spanning tree protocols. So what do I mean by that? Well, initially there was the common spanning tree protocol, and then we had kind of like the per VLAN spanning tree protocol, and then we had the per VLAN spanning tree protocol plus, and we've also got the rapid spanning tree protocol and the rapid per VLAN spanning tree protocol plus, and then we've also got the MS-TI, and then we also have the MS-TP. So as you can see, there's been lots of variations of spanning tree throughout the age. Some of these are Cisco proprietary. Some of these are IEEE open standards. What you tend to find is the IEEE comes out with something, Cisco comes out with something that's better, then the IEEE comes out with something, Cisco enhances it, Cisco came out with something, and then the IEEE came out of it. So you end up in this, like, I guess, I don't know, I don't want to say battle, but I guess it's kind of a, I don't know, trying to push the other to come up with a better technology in one sense. But obviously Cisco come up with proprietary ones in order to sell its product, because that's the whole purpose of it. And then the IEEE coming to standardize it for multi-vendor and to obviously make the market fair. But where we are at the moment with spanning tree is there are kind of 2 variations of that. The main variation that you tend to see is the one that's in this video, which is the rapid per VLAN spanning tree plus, and there is also another one called the MS-TP, the mobile spanning tree protocol. And this is also very important to understand, but outside the scope of the CCNA, this is no doubt covered in the CCNP. So the per rapid VLAN spanning tree plus is what we're interested in. Now, why have I mentioned all the other spanning trees? That's because if you go off Googling and looking around, you're going to see a lot of acronyms and a lot of confusion, and you're not going to know which options are available to you. Well, just remember this. Learn anything to do with rapid VLAN protocol or rapid spanning tree protocol, and you're good. Okay. There are, like I said, some differences between them, but effectively they're all trying to achieve the same thing, which is to prevent loops at layer 2, and they do it in the same method. Okay, and we'll get to that method shortly. So one comment I will say is that it's not that scary, but be aware. And I know it sounds a bit odd to say, but the reason I say that is because you will see many engineers not liking spanning tree, and a lot of engineers having horror stories about spanning tree, and that's because primarily, like I said previously in the video already, it's because they've set it up wrong. And a lot of people don't like to be told they've set up things wrong, but most of the time they have. Spanning tree was designed for loop-free topologies on a small scale. You know, we're talking only a few switches in diameter. It wasn't designed for massive layer 2 domains. And in most cases where there's a spanning tree problem, it's because they have very large layer 2 networks. And if you do have a very large layer 2 network and you're relying on spanning tree, then it's highly recommended to break that into layer 3 domains and to have smaller layer 2 boundaries. And that's because if there is a spanning tree error, it won't cause a major outage. But unfortunately, that's easier said than done, especially with a network that's already been built and in production. Changing a network that dramatically during production is very difficult, so it's easier said in hindsight. But nonetheless, I think because of kind of where we were with spanning tree and where we were with layer 2, it has a poor name associated with it, and unfortunately bad experiences. But design it right, design it small, design it against the specifications, the recommended best practices, add all the bells and whistles where the bells and whistles need to be added, and you're good. Okay, so that's all we've got time for in this video. I know we didn't get into actually configuring spanning tree or looking at the CLI, but it's more important that we understand what spanning tree is, why we need it, and how it's trying to fix our issues we have at layer 2. I think once you have a solid foundation of the why and the what, then the how becomes very easy, because you know what you're looking for when you look at the CLI output. In the next video, we're going to dive deeper into spanning tree. We're going to get it into packet tracer. We're going to have a play with it, understand the behavior, the route selection, the route port selection, designated port selection, and all these extra new terminologies that's going to be presented to you. So in this video, we looked at spanning tree. We looked at how it works with Ether channels. We said that spanning tree allows you to have multiple ports connected between devices, but it will disable those ports to prevent loops. But if we pop them into an Ether channel, spanning tree will see those multiple ports as one logical port, and therefore you could utilize all ports simultaneously. We explained that spanning tree is a tricky protocol, and not many people tend to enjoy spanning tree, but again, it kind of comes from the history. It's an old protocol. It's been revised multiple times. If you design it right and in the right environment, it's a great protocol. There are a lot of new technologies coming out nowadays that sort of get rid of the use of spanning tree, which is kind of exciting and new, but spanning tree is still firmly on the blueprint for all the Cisco enterprise certification tracks, so it's important that we understand it and know how to configure it. And I've also expressed the concern around designing it. We need to make sure that when we look at spanning tree, we design it correctly, we design it against specifications, we turn on all the extras like root guard, BBDU filter, port fast, all the right areas to make sure that we're actually building a correct small layer 2 domain in order to kind of ensure that our network is stable and it behaves the way we expect. The thing with spanning tree is a lot of people set it up but don't go through failure scenarios, so they don't know the path the network will take if certain components fail. And that is really key to understand your layer 2 network, because layer 2 path selection isn't as straightforward as layer 3. Now, I hope this video has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.